Alright, so, solving quadratic equations, um, there are different ways to do it. We could factor, or we could complete the square. Sometimes you can't factor many quadratic equations, so we have to rely on either the quadratic formula or completing the square. But where does the quadratic formula come from? Well, it actually just is a factoring approach, or rather a completing the square of this general expression that we have here. To solve or to complete the square on this equation here, we first need to have a 1 in front of the square. So if I were to divide the quadratic equation all the way through by the number in front of the square, which is a, it would give us something like x squared plus b over a, x plus c over a equals 0. And in order to complete the square, we would remove this term here. So I'm going to subtract c over a from both sides of the equal sign. Like this. These will eliminate, and I would end up with something like x squared plus b over a x equals to negative c over a. Now, if you guys recall completing the square from a previous video, the middle coefficient here, b over a, you take half of that and you square it. So half of b over a, and then we square that, gives us b squared over 4a squared, and then we add it to both sides of the equation. So we're going to add it here, b squared over 4a squared. Over here we're going to do the same thing, b squared over 4a squared, and then we factor this because now we forced it into a perfect square. So if I were to factor that, it would look something like this: x plus the square root of this term here, which is going to be b over 2a, equals this side over here. I'm going to rearrange it a little bit and put the b squared in the front. You will see why in a little bit. 4a squared minus c over a. Now we have to combine terms here. So notice that in order to subtract a fraction from another fraction, we have to have common denominators. I can do that by multiplying here by 4 and here by 4. However, I have a square here and I don't have a square there, so I'm going to square this guy, or rather multiply both the numerator and denominator by a. So as you can see, now we have the same denominator, so I can simplify that to b squared minus 4ca, which is the same as 4ac, and divide it all over 4a squared, equal to the other side, x plus b over 2a to the second power. And let's make some room. If I take the square root of both sides equally, this would eliminate my square there, so I would get x plus b over a over 2a rather equals to, now when you take the square root of a square, you have to get a plus or minus. You will see why. There's two possible solutions here. So we're going to get the square root of b squared minus 4ac all over 4a squared, like this. Simplifying the denominator a little bit, I will get plus or minus radical b squared minus 4ac all over the square root of 4, which is 2, the square root of a squared, which is a. And then I can go ahead and solve for x on the other side. And that would give us x is equal to negative, if I subtract b over 2a from both sides, minus b over 2a, negative b over 2a, plus or minus radical b squared minus 4ac all over 2a. And again, I have a common denominator, so I can put it all in one denominator. So you get negative b plus or minus the square root of b squared minus 4ac, everything over 2a. And this is what we call the quadratic formula, which now we can use on solving quadratic equations without having to factor or complete the square repeatedly. We can just plug it in. So let's try an example here. Let's take, for example, a simple one. Let's start with x squared minus 2x minus 3 equals 0. First of all, we first have to identify our coefficients here. The coefficient a is 1. The coefficient here is b, which is negative 2, and of course c is equal to negative 3. And if I just plug it into the quadratic formula, the rest is pretty straightforward. It's just calculating. So it's negative b. The negative of b would be a positive 2 here. Positive 2, because the negative of a negative is a positive. And then I go plus or minus the square root of b squared, which is negative 2 squared, which is positive 4, minus 4 times a, which is a 1, and c, which is a negative 3. And we are dividing everything by twice a, which is just 2 times 1, which is 2. Let's clean it up a little bit. 2 plus or minus the square root of 4. A negative times a negative equals a positive. So that's 12. And this is going to come out nice and neat, because 12 plus 4 is the square root of 16. And we all know that the square root of 16 has a perfect root. So this is 2 plus or minus 4 over 2. Now, here's a very common mistake with my students, and it probably happens a lot. They don't know what to do with this. So first we have a plus and a minus, so that means we have to do two operations. So first we're going to do the plus. So we're going to go 2 plus 4 over 2, which is 6 over 2, or 3. And next we would go to subtract 4 over 2, which of course is negative 2 over 2, which is negative 1. So therefore our two solutions, x is equal to 3 or x is equal to negative 1. That's one example. Now, sometimes quadratic functions have coefficients in the front other than 1. So let's take something like 2b squared minus b minus 21 is equal to 0. And again, a equals 2, b equals negative 1, and c equals negative 21. Plugging it into the quadratic formula, then in this case not x but b. Let's change that to b equals plus it's equal to plus or minus, see, now we're using the same variable, so I guess I should have changed that to an x, but it doesn't matter, we'll be fine. Minus b would be, in this case, is negative of a negative, which is a plus 1, plus or minus the square root of b squared. Again, don't get it confused with the variable we're using. B squared is going to be 1 minus 4ac. A here is 2, so 4a times that's 2. C is negative 21, and then divide everything by 2a. In this case, is 2 times 2, which is 4. Let's clean this up a little bit. 1 plus the square root of 1 plus 4 times 2 is 8, and 8 times 21, that would be, let me double check here because sometimes I make errors and we don't want to do that. 8 21 times gives us 168, which is nice and convenient. 168 all over 4. Now, as you can see, 168 plus 1 is exactly 169, which happens to be a perfect square again. Very convenient, right? So here we got 1 plus, now the square root of 169 is 13 all over 4. So using the positive sign first, we're going to go 1 plus 13 over 4, and then we're going to have 1 minus 13 over 4, evaluating each. 1 and 13 is 14 over 4. Then simplifying the fraction, that will be 7 over 2, and the other one would be negative 12. That's a 4, by the way, here. Negative 12 over 4, which is equal to negative 3. So our two solutions here will be b equals 7 halves, and the other one will be b equals negative 3, which gives us two nice solutions to these quadratic equations using the quadratic formula. And let's go and apply those in our homework.